Okay, welcome to day 2 of exponentials, and today we're going to compare linear, quadratic, and exponential functions. By the end of this lesson, you should be able to determine the type of function given a table, a graph, or an equation. So you should be able to look at a table and tell me whether or not it's linear, quadratic, or exponential, and the same for a graph. Is it linear, quadratic, or exponential, or an equation? So linear graphs, you're familiar with this. So recall that linear graphs look like a line. It could be with a positive slope or a negative slope. It could be with slope of 0 or a slope that's undefined. But all of these are linear functions. The equation can be in slope-intercept form, y equals mx plus b, or it could be in standard form, ax plus by equals c. Or it could be the equation for a horizontal line, y equals a constant, or it could be an equation for a vertical line, x equals a constant. But all of these are equations for linear functions. Now, we just finished quadratic functions before break, and so recall that quadratic functions, they're parabolas. They can open upward, as you see on the left, or it can open downward, as you see on the right. And remember, what dictates that is that leading coefficient. The leading coefficient is positive, it opens upward. If it's negative, it opens downward. An equation for a quadratic, the standard form is ax squared plus bx plus c. Then we also have vertex form, which is ax minus h squared plus k. But just be able to recognize both of those as a quadratic equation. Remember the main thing with the quadratic equation, the highest exponent is 2. Now, this is new for us, but it should be a review of what you learned in previous courses. These are exponential graphs. The one on the left depicts growth, which makes sense because it's getting bigger as we go from left to right. The one on the right depicts decay because it's getting smaller as we go from left to right. So you need to be able to identify an exponential function by its graph and by its equation. So it looks sort of like a times b to the x. What distinguishes an exponential function is that the variable x is in the exponent. That's what makes it exponential. The variable x, or t, is in the exponent. Okay, so we're working on this exploration activity that you have. I'm going to kind of do it with you. So what type of function is this? You should be able to tell me what type of function it is. And you are correct. It is linear. So we're going to do an xy table for it. I've given you the x values. To find the y values, we're simply just evaluating it. So 2 times negative 3 is negative 6. 2 times negative 2 is negative 4. So you just want to complete that table. Okay? Now, here's the neat thing about a linear function. If I subtract my y values, if I get the same value each time, then that makes that function linear. So in this particular case, what I'm subtracting is negative 4 minus negative 6. Why negative 4 minus negative 6? Those are my y values. So I am subtracting my y values, and I'm going to see that I'm going to get, so I'm doing negative 4 from here, this negative 4 minus negative 6, and that gives me positive 2. And then I'm going to do negative 2 minus negative 4, and I get 2. Then I do 0, so I'm taking that second value, so I'm doing 0, can you see that, 0 minus negative 2. So if I get a pen here. So I'm taking 0 minus negative 2. And then I would do 2 minus 0, 4 minus 2, and 6 minus 4. And notice each time, so I took the second number, subtracted it from the first and the y values, and notice each time I got the same number. If that is the case, then that makes the function linear. And we call that They called it first difference. A lot of times it's referred to as the common difference. And that common difference between the y, if that common difference between the y value is the same, then it is a linear function. And notice there's a relationship between the common difference and the slope of the line. Now let's look at a quadratic function. So in a quadratic function, we're just going to take those values and plug them into x again, into our function again. So -3 squared, remember -3 squared, oh, this is a quadratic function. -3 squared is -3 times -3, which gives us +9. Then -2 squared is +4. -1 squared is 1. Remember, if you're putting this in your calculator, remember you have to put parentheses. So you have to do parentheses -3, close parentheses, then squared. Otherwise, you get the wrong answer. Okay, and so going on, one thing we notice about quadratics, especially if we do it around the vertex, our y value should be symmetrical. But that's only if we do it around the axis of symmetry or the vertex. Okay, so now we're going to look at the first difference like we did for linear. So we're going to do 4 minus 9. We get -5. And then we do 1 minus 4. And we get -3. Then we do 0 minus 1. Now notice that my common difference is not the same. And 9 minus 4 is 5. My common difference is not the same. Okay, so how do I fix that? Let's look at the second difference. So the second difference is -3 minus -5. And that's 2. And then I do -1 minus -3. 1 minus -1. 3 minus 1. And 5 minus 3. Notice my second difference is the same. Now it doesn't have to be 2, and it has really very little relationship with the original quadratic, but that second difference, if that second difference is the same, then we say the function is quadratic. So the first thing we want to try is to find the first difference. If it's the same, it's linear. If it's not the same, then let's try the second difference and see if that's the same. And if it is, then it's quadratic. Okay, now I've changed this from what your paper has, so you want to change that first and second difference on your paper. Mark that out and write common ratio. Okay, because if it's exponential, it's going to have the same common ratio. This is exponential. Okay, and it's exponential because we have a variable in the exponent. A variable in the exponent makes it exponential. That's what makes it exponential, a variable in the exponent, okay? So again, we're going to put these in. So remember, 2 to the -3 can be written as 1 over 2 cubed, which is 1/8, sorry. 2 to the -2 is 1 over 2 squared, because remember when we have that negative exponent, it goes to the bottom. And this would be 1 over 2 to the first power, 1/2. And then anything raised to the 0 power is 1. And then the next one would be 2 to the first power, which is 2. 2 squared, 4, and 2 cubed, 8. Now what we're looking for is a common ratio. So we're taking 1/4 and dividing it. The last time we subtracted, but if it's exponential, we're going to divide. So we're doing 1/4 divided by 1/8. And you can do that on your calculator if you like. And then we're going to do 1/2 divided by 1/4. Then we have 1 divided by 1/2. And 2 divided by 1. 4 divided by 2. And 8 divided by 4. And we notice that all of these are the same. And it's going to be the same as this base. So a function is exponential if the common ratio between the y values is the same. So if I can take the second value divided by the first value, if I get the same number each time, then we say it's exponential. And whatever I get, that's going to be my base in my exponential function. Okay? All right, so that's all of that first page. What I want you to do is I want you to pause this video and I want you to try the back of this page. So when you're doing that, remember the first difference is the same, the function is linear. If the second difference is the same, the function is quadratic. If the common ratio is the same, then the function is exponential. So could you pause this and try the problems on the back and then come back and look at the answers? Okay, so looking at that first one on 2a, we see that that function is quadratic because the second difference is 2. 2b, the function is exponential because the common ratio is a half or 0.5. So when I do 16 divided by 32, I get a half. C was hard to determine because the x values are not increasing by 1. I think it's exponential even though there's not a common ratio, but I just want you to know there will not be any like that on your test. Okay, and then 2d, the function is linear because the first difference is 0.2. So we're adding 0.2 each time in 2d. And then when we look at the bottom, those are kind of the answers to whether or not it was exponential, quadratic, or linear. Please remember that if it's exponential, the variable is in the exponent. If it's quadratic, the highest exponent is 2. And if it's linear, it's written in the form of y equals mx plus b or ax plus by equals c. Okay? That's it for this lesson, and there's a online assessment for you to complete by the end of the day.